G'day. In this episode I'm going to do a bit of a review of these two little robotics kits that I've had for well over 20 years now. They're a Velleman kit, which is a Belgium company. I think I would have bought these from, well, there's a sticker on this one saying Dick Smith Electronics, but that was like 20 years ago, but to this day they're still available. This is the latest Altronics catalogue here in Australia. And they're both still available in this catalogue. The crawling Microbug kit, around about $25 dues, and the Velleman running Microbug kit for $16.50 dues. So they may be old, but you can still get them in the current catalogue here in Australia anyway. Altronics do a lot of Velleman kits. So they come in, obviously I've already assembled them and put them together and so forth, but they come in these little blister packs. And the only instructions you get with them is this bit of cardboard backing, which in fact opens up and gives you the kit construction details. There's quite a lot of information here condensed in a way that only Europeans seem to know, with a lot of pictorial sort of instructions, with a lack of detailed language instructions, obviously, because of the limited space involved, and you've got to try and juggle the millions of different European languages. On the back it gives a description of all the functions in each of the languages. Inside there's a brief tutorial on how to solder. The resistor color codes are given, as well as all the other components, polarities and so forth. And there's also a circuit diagram for each of the units. So both are very similar in their construction details, and in fact the circuit diagram, circuits are very much the same. Both devices have a simple pair of DC motors, and that's the locomotion is directly off the end shaft of the motor. Just a bit of wire insulation has been put over the metal shaft to provide a bit of friction for its propulsion methods. And there's a little roller, a nylon roller on both units to support the back end of each. Now, both of these are what they call photophile or phototropes. There are some light dependent resistors in each corner on the front, or LDRs. This one. And the idea being is that they both seek light. And they're drawn towards the light, so to speak. Only a handful of components, really. We've got your two motors. There's a bunch of resistors and some transistors, an on-off switch, a battery pack. There's a couple of pots there to adjust the sensitivity, and a couple of LEDs which sort of act like they sort of visually they sort of appear as the eyes of the creature, but in fact they actually display which motor is driving at the time. Both of these units do exactly the same thing with the LEDs, the LDRs. This one is a little bit more sophisticated, and we'll talk about that in a minute. But it also has two pots with the sensitivity of the LDRs. In both cases, the motors are just soldered in place on the main board, and an on-off switch, and this one has an additional function switch which we'll talk about as well as a speed pot. So let's turn this little one on and see what it does. Oh, it's pretty quick. I've actually got a little laboratory power supply here. As you can see, it gets drawn towards the lights. It doesn't fall off the edge of the table. You can turn down the sensitivity of the box. Increasing the sensitivity just gets out of control because of all the light I've got for the camera. So yeah, it's, you need a little bit more of an open space to play around with these, but as you can see, it's exhibits its own little sort of behaviour. Let's have a look at this one. one's going. There we go, I just didn't have the sensitivity about the same. Alright, so how do these little fellas work just with a bunch of transistors? You may wonder. So let's have a look at the circuit diagram. Excuse me, for the simplest of the two. Alright, might be a little bit hard to read, but hopefully you can see that alright. For this one, there's actually two identical circuits, and what they've done is just drawn one of them. So they're just showing the switch there as the power supply. Here is our LDR, light dependent resistor. In series with a current limiting resistor and another resistor to adjust the sensitivity. So that's your pot, adjust the sensitivity of the circuit. So that's biasing a transistor here, a BC547. And that in turn is turning on this other resistor of 557, which drives your motor. And there's a current limiting resistor through an LED, which displays when the motor is driven in parallel with that motor there. And that's all there is to it, really. Very, very simple. So even with that simple circuit, it's able to exhibit some interesting behaviour. Certainly nice and quick. Yeah, the other robot has an additional bit of circuitry, which we'll have a look at. Hopefully you can see that all right. Essentially, well, it's got the full diagram here. It's pretty much identical, this part of the circuit, to the previous one. The light dependent resistor through a current limiter and a sensitivity adjustment pot, driving a 547. and which in turn turns on this 557 with the motor, the LED, through its current limiting resistor. And so there's one for each. What makes this one different is we have two additional transistors, 547s, and they're configured as a astable multi-vibrator via this RC network, which sets your time constant, and that is adjusted with your speed control pot. So once again, we've got a power switch, but there's an additional switch here which can switch between two modes of behaviour, so to speak. In the first mode, both of these transistors here are driven just by the square wave pulse at the same time, so they're both in phase. Both motors drive together, so you'll see the robot sort of pulse along, so to speak. When you turn the switch down here, this transistor remains driven by this pulse, but this pulse, which is out of phase, which is high when this one's low, so they drive the motors out of phase, so you'll get that sort of left, right, left, right, left, right sort of behaviour. So let's just demonstrate that a little, so it's a bit more clearer. This is with both motors together. And we can switch it so you can see it gets that wobbling behaviour as each motor is driven out of phase. So as you can see, there's some pretty cool insect-like behaviour just with a handful of transistors. Once again, this is a class of robotics that's called analog robotics, or I think you call them beam, B-E-A-M robotics nowadays. Pretty cool, fun toy. Quite cheap, really. And as I said, I built these more than 20 years ago, but they're still available in Australia anyway, but no doubt any good electronics kit supplier would still carry the Velleman kits. Alright, well, I hope you enjoyed that, and we'll see you on the next episode. Cheerio.